Hello everyone, welcome to Proceeded. So now we have to do the question that we left in the past, left in the last lecture. So basically there are n houses, each contain x coins. I mean x is basically different, so each contain ai coins where I where 1 less than equals to I less than equals to n. So for this robber has to write a function, or you can say he has to rob in a way such that he gets the maximum coins from all the houses combined. And the conditions are, if a robber robs a house, then robber can't rob the house again, or he also can't rob the adjacent house. So for this, your intuition should be, you can either take it and skip the previous, or you can skip it and take the previous. I'll basically buy this. Let me explain this to you. So suppose there is a house, there are 4 houses, and suppose this has 2, 1, 6, and 10. So for the first example, we have, if we take this, then that means dp0 is equal to, basically what your dp will be, you have to always define what your dpi will be. So it will be maximum money till index I. So basically you have dp0 equals to, so dp1 is equal to maximum of 2, 1, which is 2 again. Now suppose if this 2 was not there and you had to include 1 with 10. Well, here you will have to do that. So for dp3, dp2, you will have maximum of, so these two are defined. So for dp2, you will have maximum of dpi minus 1. This is basically just the same. So your dpi minus 1 is 2, which is a house previous than this. Well, basically, if your answer is this, that means this won't get included in the array. So not this. If your answer is 1 or whatever it was coming till 1 and 1 is included, then your answer will be max of dpi minus 1. Otherwise it will be, if this has to be included, then the answer will be this plus this. So you have to just choose whether you have to take this, the previous one, or the third previous one, or the previous one before that. Basically in this also you have to take for n minus 1 and n minus 2. You just have to check for them. So in 1D-DP you mostly follow these 3 things, n minus 1, n minus 2. So whenever you get for this, you can just remember that you have to use 1D-DP. So basically if maximum dp is max of dpi minus 1, then you'll have dpi minus 2 plus ai. So you can either choose 6 and 2, or you can choose 1 and 10. Basically you can either choose 2 and 6 or 1. So suppose if this was 2, 10, 6, 10, then over here your answer would go from dp, well basically dp0 equals 2, but dp1 equals 10. And suppose if your dp2 is equal to dp of 1, maximum of dp of 1, in this case this, otherwise in this case this. So you chose I minus 2 and then you can just add this, and you have to either take 0 plus what was the case again? So you can either take 0 or ai. Basically this should be, this is 10 and this one is 8, so you have to choose dp1. So you just have to find the rest case if n minus 1 and n minus 2 are there. Basically I minus 1 and I minus 2, then you have to use 1D-DP, and for 2D-DP you'll have to check some other case. So first 1D-DP is done. So for that we have the logic dpi equals dpi minus 1 comma maximum of, sorry, not maximum, comma dpi minus 2 plus ai maximum of this. So this is one which you can remember, and rest of them you should be able to understand. So basically this also you should have understood. So and dp0 equals a0 and dp1 equals maximum of a0 comma a a1. And for this you have to loop from I equals to 2 to I equals n minus 1. So why I equals to 2? Because you have dpi minus 2 which will give dp2 minus 2 equals dp of 0. So for this you have to start from 0, sorry, 2, and it goes all the way to n minus 1. Suppose if it is a smaller than dp0, I mean if the size of vector is smaller than 2, then what you have, you can just remember that equals less than equals to. Then also it works because it won't go in the loop. So basically for dp1 equals maximum of dp0 comma dp1, you can just check. You can use this if I greater than 2, if n greater than 2, sorry, if n all equals, or you can say n equal n greater than 1. So for that you'll have this, and if n not equal to 0, then dp0 equals a0. Basically if there is some size, then you can write this, and if n double equals 0, then you can see out minus 1. Well, basically I haven't been telling what you have to do for 0 size or 1 2 size vectors. So this is what you have to do to check them. So that should be easy for now. So let me just write the code and then you'll get at what I want to say. So basically you'll write dp. Once we have written this, we can just go with the flow. In contest, you will be given what the range of n will be, but here since we are not given anything, so I'm writing this if n greater than 0. Basically in systems you will have to use these conditional statements much more than you use in competitive programming. So for system design you have to always remember that you have to check everything, not just the constraints are not starting from 1, because they can start from 0 too. So now we have to see out. Once we have written the code, we should check whether, or we can directly write n minus 1. But if n equals 0, then we'll have some problem. So we'll just check if n is not equal to 0, then only we see out dp. Otherwise, we see out minus 1. So once we have done this, now suppose we don't pass anything over here, just pass 0. Then we'll have minus 1 as the answer. Okay, so I've written something wrong with, okay. Okay. So basically I did this. Okay, so this was the problem. Okay, so there was no error basically. It was just a syntax error. So we have minus 1 as the answer for 0. For 1, you should have the answer dp0, which is a0, which is 2. Okay, so we are getting 35. I know why this is happening, because we might have not allocated anything. Basically, if n greater than 0, dp0 equals, okay, so it was supposed to be n double equal to 0. Oh, sorry, n greater than equal to 0. And this was supposed to, no, no. Because n minus 1 is there, so yeah. So it is greater than 1, then we have, okay, so this is correct, this is correct. Oh, okay. Basically, we can either write if n, basically we have to start from 2. Well, I told you, but I forgot to do that here. Basically, where here I told you, loop from I minus 2 to I equals n minus 1. So we have 2 as the answer. Next, we have 3 and 4 and 2. This should give us answer as 4. So basically, we'll have 4 as the answer. We have it now. Next, we have 10. So basically, this will take 3 and 10 as the output answer. So basically, it will be 13 as the answer. 13 should be our answer. Okay, so we are getting 4, which is wrong. So why is this happening? Let me just see that and then tell you what is happening. So for dpi minus 1, which is basically n minus 1, which is basically your dp2. Okay, so for 2 also we have to check. No, for 3 we are, okay, sorry, we have 3 as the n, and then we are getting for dpi, which is n minus 1, which is 2. dp2 equals max of dp1, sorry, dp0 1 comma dp0 plus ai. So basically we should get 13 as the answer as per the code. Okay, so I'm still getting some problem. Well, basically only problem could be that we are doing some wrong cout over here. If n not equals to 0. So basically if n is greater than 0, then we have dp0 equals a0. If n is greater than 1, then we have dp1, and so on. Okay, so I wrote 2 over here. That's the problem. So we took the wrong input. Basically n was the problem. Well, for 3 size array you have to take 3. So basically it was just taking 3 and 4 as the input and then leaving 10 as it is. So for next we have 4 and we'll have 11. No, actually we'll have 8. It should give us 13 as the answer. Well, because 8 4 is 12 and 10 3 is 13. Yeah, so 13 was the answer. Now suppose you don't want these two, so you will just fill them with 1 and 2. And then you have 3 as the input and 8 as the input. So basically answer should be 11. Yes, so you're getting 11 as the answer with this code. You can just verify that condition also. Basically, you just have to think of it. Next, we have 2D-DP. So in 2D-DP, what you should do basically, let me first create the chart, then I'll be telling you what 2D-DP is. Well, so I'm back. So next we have 2D-DP. Well, let me change the slide. Basically for 2D-DP, you have first example, you have subset sum. Basically you can do subset sum without DP, but that'll just give you TLE in many problems, or you can use some other methods to, basically that will be tabulation only which you'll be using. So first I want to try it yourself, uh, in whichever way you can, and then try to optimize that thing, and then you can come back here and then we can just solve it using DP. Okay, so if you are done solving, so we can just move to the question. Sorry, I didn't give the question. You are not done solving. So basically you have been given an array. So given an array, can you pick can you pick a subset? I've already taught you about subset in, I believe, backtracking lecture. In lecture 12, 13, 14 or 15, I have taught you about subset. So can you pick a subset whose sum equals target? Basically you are given a target value and you are supposed to tell whether you can get this value from by adding any number of integers in this, you can say, in this, what do you call it, in this array or vector. So first you have been given an array. Basically it can be double type also. Well, we'll solve double type question 2. So next you have been given a target. Suppose the target is 7 to 9, and suppose there is one more target 1, and then we'll practice on target 2, which is 11. So if you are given, basically we'll have multiple targets for the same this array. So you will make a vector of target, vector and target, and then we'll check this in one go. So at first you have array and you have to find whether the sum is equal to 9 or 11. Well, first let's go with 9. So for 9 you can check 2 plus 3 equals what? Well, basically intuition doesn't change. Intuition is same. It is to either take the number or skip it or don't take it. So basically this is also a decision DP. So next we have DPI sum. Basically what is your sum? Well, first let me just tell you what we'll be doing in our 2D-DP. Well, why do we need a 2D-DP over here? If anyone is able to answer that, then you are good to solve it yourself. First try it yourself, then you can just come back over here if you are unable to solve. So if you don't know why we are using 2D-DP, let me tell you. So suppose you have been given a DPI, and then you are asked to ask for, you have to take the sum from here. So basically that sum can be formed by multiple possible combinations, and also that sum might not be correct. So basically like we were doing in last, that we are just doing DPI equals DPI minus 1 plus I minus 2, or we are doing max. So over here we are not doing this because we basically have this sum in which you have to, Well, you basically have to just collect the sum and you have to check this too. So till I, what sum you have, and for all, if the sum equals target, then you can just go with this. Otherwise, you can't. So basically, once I'll be coding, you'll understand that. So for now, you have DPI and sum over here. Basically, we'll write it as J, but I'm currently writing as sum. So it is to check whether can we form sum using first I elements. Then next we'll have to subtract each sum with the array, basically with the character of that stuff. This will just give us the next possible combinations of sum. So basically we'll have dpi and then sum minus array. So basically what I want to say over here is, for a single DP, it's not a single DP, I mean, it's not a 1D-DP. So you are not just storing values straightly in this. So instead of just storing values one by one, you have a 2D DP. Well, basically you can represent this on graph too. Okay, I didn't tell you how to represent vector in graph. Well, that's my bad. Well, basically I'll be teaching that on the website because there's no need if you are able to understand that already. So basically you can go to course seeded, course hyphen. Well, this is very important. You have to use a hyphen and then seeded. Search this on basically Google or any search engine. You'll get courseseeded.com and then press on that website. Basically, I haven't started the courses yet because they are going to start from 1st or 5th May, and the second one will be starting from 10th of May. So I'll be waiting for you all over there. So for this, we have courseseeded.com, and then we have, okay, so where was I? So I was over here. So for 0th index, since your row is I, so basically this is I, 1, 2, 3, and this is J or sum. I, 2, 3, 4, 5, 6, 7. So basically with I equals 0, you can just, you just can't do multiple things in this. So basically what you have, if this thing is true, you can input this as true or false. So basically you just have to put this as well, or true, I would say. Then you will have, well, you can either do boolean with this, or you can just store the sum and then check it. So we first prefer bool because we just have to check yes or no. So we prefer using bool data type. You can just use integer too. Anyways, so for DP I sum minus array I minus 1 will have true over here stored. That means that this value has to be stored in DP, and afterwards we'll check for each value. Basically we'll just do this for all of them over here. Okay, so actually, okay, so basically our, this is the, row. So we'll be doing for the 0th column, not for this. So first we'll be doing for this. Well, you can basically change this to sum minus array I, and then you can change this to I. So that way you can just take these as 1 and then these will just remain as 0, or you can say as nothing. Anyways, so where was I? So first, if you're done with this, then you just have to check whether sum is possible or not. Okay, so first you'll have to think what actually your answer could be. So basically this has to be of the target size. This has to be of the size of target plus 1. And this has to be of size n minus 1 basically. No, actually not n minus 1, but n plus 1 size. Well, basically this will give you dpn, and this will give you dpn and target. So you'll reach the target whenever you need. So what I was saying is, whether you have to include this or not, you just have to check that. And once you are done with checking whether you can include this or not, then if you get the target sum, now suppose if you don't get the target sum, then you just have to output -1. So what you will be doing is, you will check whether array of I minus 1 is less than equals to s. Well, why are we doing this? Well, basically to check if our DP can just, go with the size. Basically this is sum, so it can check whether you have the, you know so no, this isn't the sum, this is basically j. Well, basically you are understanding me, right? Basically this was the sum and we took it as j, so I'm just checking for j. Now suppose if you had sum written over there, then you had to do sum. So basically this is sum only. So area I minus 1 is less than equals to j, then you just have to go with dpi s equals dpi minus 1 s, or dpi minus 1 s minus area of I minus 1. Well, if you are unable to understand this one, then you can just count me in. I'll be just teaching this again in a better way once I'm a proficient teacher, or you can say a better teacher. So you can either wait 1 or 2 days, so I can re-explain this, or you can just learn it over here. So basically, why are we doing this? Well, basically to just check whether dpi minus 1 s. Now suppose if this was true, okay, so that means if this was true, then we don't have to take. Well, basically this tells us we have to take or not. So basically if this is the case, then we don't have to take. And suppose if this is false, basically, then we don't have to take. What do we say? We don't have to. What am I saying? We don't have to make it true. Or you can just check I minus 1 and s minus array of I. If this is true, then you have to take. This tells you whether to take, and this tells you not to take. So basically if you have this over here, 0 0 0 0 0 0 0 0 1. So basically for DPI you'll have this to be taken, so you'll always take this over here, and then you'll have to check for these stuff, and then these, and then these. So I was saying that if this, if array I is greater than equal to s, sorry, less than equals to s, then you have to decide it using this, which I've written over here. Or you can say if array I is greater than s, then you have to write dps, basically dpis equals dpi minus 1 and then s. So why are we directly doing it over here? Because if this is already greater than s, then obviously, it is very obvious that you will decide on I minus 1 whether we had to include this or not, right? So if it is already created, then you can decide on the previous one whether you have to take this or not. Well, basically S is RJ. Let me write J everywhere. And RJ is basically target value. So we have this. That looks perfect. So let's write the code now, and then we can just go to the next part. Let's leave n equals to 0 and 1 other test cases. We can just write it directly over here, or let us take them. It won't hurt to take them, so I'm just basically let's just remove errors. We'll just take our time. Basically, we have this. Then we can just check whether this is true or not. So then we can just see out. Well, this will give us a true or false, whether we can achieve the target or not, as 0 or 1. So basically, if it is 0, then it is false. Basically, we can't reach the target. Otherwise, we can reach the target if it is 1. So let me first write the code, then I'll be explaining you thoroughly what I mean. I think if I write J, you might get confused in future after seeing the code. So I'll be writing this as sum equals 1, and then sum less than equals to target, and sum plus plus. In future, you might get, when you want to revise, you can just know what you're doing. So if array I minus 1 is less than equals to sum, then you have DPIS. Okay, so this was the first case, and then second we had, so we have these two stuff and these two cases. So now we'll be just returning DPN and target. Or 3128. Okay, so I didn't write the target. Physically, it is not possible to form 7, so we'll get 0 as the output. Okay, so okay. Vector bool target plus 1 comma false, and then double. So what's wrong over here? Let's see what I'm doing wrong. Okay. So basically, we wrote bool over here instead of vector bool. So next we have, it should be correct. Okay, so okay, so this was a not array. Well, actually, I remember this from first lecture. Okay, so we are getting runtime error now. So what's wrong over here? Understand. Okay, so should I be storing it as 1 to n? Well, let me just see that. So first, okay, I get it. No, actually, I didn't get it. Basically, we have this as ARR. Then, then. Well, to me, it looks everything is perfect. Let's actually see what you're doing now. So some minus array of minus 1. Okay, this is correct. So basically, n is the size of the array. That's correct. Next, what do we have? Mm, Actually, this keeps happening with me. I just don't know when I'm teaching you all. I just encounter some error. Okay, so I believe this has to start from 1, or it can start from 0. There's no problem in that. But this one has to start from 1. Yeah, actually, this is also good. Okay, so nothing is wrong over here in the code. So looks like we are doing some error somewhere else. Why am I getting runtime error? Well, let's rerun this and see if the problem persists. Because it does persist. And I just have to call for DP and target. Integer and target and then vector and an. It's just okay. So now we are doing a I minus 1 for array, so it's correct. Then where are we facing the problem? And why is it giving us runtime error? Let's reload the compiler and then see if this problem persists. Basically, most of the time I'm okay. So I didn't. Let's tell some runtime error. DP and target. This is actually correct. We have n and we have target. We have DP as n plus 1 and target plus 1. False as the first value, or you can say as the default value. And we have for integer I equals 0, I less than equals n, I plus plus DP I 0 equals true. This is also correct. Then we have this, and it looks perfect to me. And next we have, okay, so there is no problem. Let me just change this a bit. Well, actually, this will give us wrong answer, but let me just check whether it just removes runtime error or not. Well, we should get wrong answer over here, but let's just wait and find that out. Because we are still getting runtime error. Okay. So let me first pause the video and then check whether where I'm wrong. Then I'll be telling you what I've done wrong. Well, actually, I am so much of a pro that I forgot that we have to return a value in function. Well, basically, we didn't write the uh, return this over here. Well, basically, this was written, but I forgot to write the return. Well, it's my fault. So basically, yes. So there exists. So basically, I can do. Yes. Now I have written the code. Now I'll be explaining you what I did. Yes was the answer, and then suppose we change this to 5. There's no way we can find 7 in there. No way. No, actually 5 and 2 can make 7. Let's choose something that can be made. Basically, no, not 0. So you're taking, basically, we'll be taking 4. Okay, so 3 1 is 4. Wow. Okay, so we are not left with any choice. Well, we'll be taking something bigger than what this all can make. 5 3 and then 3 6 11. So 12 can't be made. It should give us the output as no. Yes. So let's go back to this and then check what we have done. So basically, first we have written for I equals 0, I less than I plus plus. Basically, for I equal to 0 to n, we have dp I and 0 as true. So for this, what we are doing, we are basically performing an operation on our dp. Suppose the target was just 12. Basically, there are, suppose the target was 4. Target equals 4 for now. 0 1 2 3 and then 4. So this target can always be achieved for all of these. Why? Because 0 can always be achieved, as you all know. Basically, we'll be performing 1 for everything. So basically 0 1 2 3 and then 1 more. Okay, so there's no need of 1 more. We can just explain in this. So we can always have the sum equals to 0 without typing anything. So that means that we can write 1 always over here. Now suppose if there was 0 1. So basically, can we form 1 with this? Well, what we did is basically we wrote dpi s. So for array I and then I minus 1 less than equals to s. We have dp I and s. Basically, this is our sum. I'm writing it as s for now. So for our sum equals 1, we have dpi minus 1 s or dpi minus 1 s minus array of I. So what we are doing over here, we are basically checking for this condition. If it is less than or equal to s, we'll check whether dpi minus 1 s is true or this thing is true. If any of them are true, then we return dpi s as true. So basically dpi and currently 1. So we have dp01 as true, even though this doesn't give us any real input, but since this is less than equals to s, we just write it as true, and then so on. So what was our dpis? We are checking dpi minus 1s, and then we are just checking whether dpi minus 1 s minus array of I is true or false. So if this was true, basically sum and dpi minus 1. So this thing exactly, to be precise. Okay, so for 0 we don't have any I minus 1. I'm so sorry for that. So we are basically starting from, okay, so this all was 0, this all is set to 0. So for 1 we are checking, well, basically this way I wrote for in the for loop of I equals 1 2n plus 2n. So we are starting from 1 basically, and these all are set to 0. So for dpi minus 1, we have this as 0. So 0, or we have dpi minus 1 s minus array I. So what was our s? It was basically 1 minus array of I, which was 1, 2, 3, and 5. Okay, so we had dp s minus 1 minus 1, which was 0. So basically we had this as 0. Well, you can either memorize this question, because this can be used for multiple questions later, or you can just understand this over here. Basically, there is a mathematical proof behind this, but I can't really tell you how we get the mathematical proof. Well, because that video will be around 2 hour long. At least in my case, it will be 2 hour long. So you have 0 or 0. So this was basically 0 by itself, because you have dp1 and 0. dp1 and 0 was basically 1. Okay, so this is 1, not 0. And we have array I minus 1, 1 is less than equal to 4. Else we have dpi s equals dp of I minus 1 s. Well, there is a smaller and more optimized way to solve this problem. But first you have to understand this to get to that optimized approach. So for this we have target equals 4, okay, and we have 1 less than equals to 4. So it will ask for this, and we have dpi minus 1, which is 1, and then we have dpi minus 1, which is again 1, and well, wait, dp1 4, or okay, so this is, and so basically this will be true. And next we have dp2 and then s, which is basically 1. So all of them will be 1, because as you can see that we have s minus array of I. So basically for this we'll always have 1 till the time this is not there. Basically array minus 1 is greater than s. So till then we'll always have 1 as the output, and that's a good sign because we need 1 as the output. Now suppose you're asked, why do I have to check whether this can be taken or not? So basically this has to be taken or not taken depends on our dp. And for I equals 2 we have dp2 comma 2, sorry, 2 comma 1 equals dp. Well, basically you can check and it will all come as 1 up till the fifth one, and then you will just have to check for that. So basically you can just check it yourself for each and every dp for this example set. Well, basically for example n equals 7, k or target equals, basically write it as target, but in exams will be given it as k. Target equals 12, well, basically keep it as 4, and array equals 1, 2, 3, and 5. You just have to check or create the complete dp of code, dp of code manually. Well, basically what we can also do to check that, you can basically just return dp. Well, you can either do this, and then we can just take the DP. Then we can just see what's happening in the DP. Okay, so we have this. Now we can just run this. Okay, so I didn't use auto variable, and we don't have any DP over here. Basically, we yes, now it should be perfect. Okay, so we have true, false. As I said, that these all will be true always, and these will be false always, and these will go up to true if you have the value suggested that either these two are good or not. Well, most of the time you'll get some values which are out of bound for this maybe, but since we use this condition, if array I minus 1 is less than equal to sum, there will be no out of bound problem in DP. So that's why I use this condition. And then for else we have I minus 1 or sum. So that's the reason behind using this condition, nothing else. Then we have true, 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 and then we have false at last. I suppose I just show you this to you at 4. Well, this will give us true. Well, true, and then true, and then we have 3 trues, and then 2 trues. Basically, this won't change because the logic is just to check whether the sum is there or not. So basically, this will always be same. The pattern will always go same. If you are able to understand the pattern, then you will be able to see that everything will go like this: false over here, then few more falses, then few more falses, then basically one more true, and then few more falses. And this will go 3 more trues maybe, and then false. All the other are false. Well, for this only, suppose I change this, everything will change. Let me just change 1 2 3, and then I'll be using 1. Okay, so we should use 4. Now suppose if I change this to 1, what will happen? Well, basically it should give us the output as true. So yes, it gave us the output as true for n comma target, which was 0 1 2 3. So 0 1 2 3, it gave us true as the output. So basically this was our output for 3 comma 3, which is true. So everything changed, but this was exactly what we need. So anyways, this is it for today. Thank you everyone for joining. So basically this lecture is a bit longer than usual, and I might not have been able to teach you exactly what 1D-DP is. Basically it's not a one day concept. So in the next problem use I'll try to come prepared, like, to make you understand that. in a way that it's much easier than this. Basically, I was just telling you what's happening, what it is, and you might not have been able to understand because it was all code based. Next time, I'll try to bring math proof too. So, thank you everyone. Thank you today. In next lecture, we'll be doing math proof of that.